Okay. So now let me come to the next important thing, which is error analysis. So far we were talking about the accuracy of the model, how much accurate it is. Okay. I am saying my model is 90% accurate. So that is accuracy, not error. If my model is 90% accurate, there are different ways of explaining accuracy. One of the ways you can say out of 100 times, 90 time it is correct. That is what is 90% accuracy is. That out of 100 predictions it do, 90 predictions are correct. But still, that does not tell you about the error of the model. Now, what is the error of the model? So, how to calculate the error of the model? Let's look at step by step. So, for error, we will do actual minus predicted. So that's what we were seeing. These are the errors. Okay. But now we have to understand about some important things here. Okay, guys. So understand this properly. This is a very, very important thing I am telling you, that you already had the actual value and then you have predicted values, y and y hat. So what is an error? Error is actual minus predicted. Okay. Okay. In the field of machine learning, we not only look at error, but we look at something known as squared error. So what is that? E square is nothing but y minus y hat square. That is squared error. Some people say, no, I'm interested in absolute error, the absolute value. So y minus y hat absolute. So means it will remove the signs, like every value. Let's say even you have -3, it will become 3. You will take absolute value. If it was +3, it will also be 3, right? So you ignore the signals, the signs. You ignore the signs. So this is squared error. This is absolute error. But now in the field of machine learning error analysis, we talk about something known as mean squared error, MSE, root mean squared error, RMSE. Okay. So from this squared error, guys, you can always deduce this formula. What is that? Mean squared error is nothing but, you already know the squared error, right? But that squared error is for every value. But let's say there are 100 records. So you will do summation of I equals to 1 till 100. You will add all the squared error and divide it by 100. That is mean squared error, right? You take the squared error, but now there are 100 records in the test data. So you will add the squared errors for all the records, divide by the total records. That is mean squared error. What is RMSE? It is nothing but taking the root of mean squared error. That's it. Similarly, if you know absolute error, AE, we have something known as mean absolute error. So if this is the absolute error for the first record, I will add it for, let's say, all the 100 records divided by 100. That is mean absolute error. Okay. There is something known as MAPE. That is mean absolute percentage error. That is another formula. But what I am trying to tell you here, guys, my intention is that these formulas are not complex at all. MSE, RMSE, MAE, MAPE. If your foundation is clear, you can write these formulas, right? So you know what is MSE, RMSE. These are the two most important formulas for error. So guys, from sklearn.metrics package, I have some functions available for MSE, mean squared error, MAE, mean absolute error, mean absolute percentage error. See, for MSE, you have the formula. For RMSE, you don't have. No problem. You will use a root over MSE, you will get it. I will show you. So now what we are doing from sklearn.metrics, I will be using these formulas. See, simple. To calculate MSE, I am calling the mean squared error function, passing my actual and the predicted value. So what I am doing, I am passing my actual value y and the predicted value y hat. It will internally calculate first E, means the error, then the squared error, and it will do the mean of it. And that is the mean squared error, guys. A very huge error because it's a squared error, so it will be very high. And what I am doing, RMSE. I'm importing math package. I'm using a square root function of the math package, passing the MSE value to it. So I'll get the RMSE, right? I already have the mean squared error. I will use a square root function. I will get the RMSE value 5774. So RMSE is square root of MSE. See? So similarly, you can calculate MAE or MAPE, MAE, MAPE. But if now anyone asks you these formulas, you can very easily calculate and tell them mathematically also. But why we should use RMSE, guys? Because RMSE is the actual representation of my error. Before I conclude, you understood RMSE. So RMSE is a good representation of my error because this is a very huge value because of its squared nature. So taking a root will make me closer to the actual value 5774. Now I can say that if I had to predict the loan amount as, let's say, 10,000, for example, or let's say 1 lakh, if I had, whenever my model is predicting, let's say, any value 1 lakh, there will be a plus minus of 5774 error. So if model is saying I can give him a loan of 1 lakh, there will be always a error of 5774 in predicting this. And that's where I am saying RMSE should be used rather than MSE, because you cannot compare this huge value to the actual value. So that is very important, that okay, MSE is good, but RMSE can be compared to the actual prediction because it's nearer to the actual scale uh, rather than MSE. So ultimately, to conclude this, guys, this is the conclusion, that this model we used is seems to be a good model. Still there are opportunities to increase its accuracy, but still you can see it's good. But yeah, RMSE is high. 5774 is still a high error. We have to still reduce it, and that's where we will try better models like ridge, lasso, decision tree, random forest in the upcoming sessions. We will talk about these advanced models. Linear regression is the simplest model. Normally we should use its generalized versions, or we should use ridge, lasso, elastic net, or maybe some advanced models. That's what we will be talking. So that's it for today.